You know you're not supposed to use GlobalScope, but you've got to get a scope from somewhere, right? So where do you get it from? There are several options, so let's look at them and see when you'll want to use each one. It's easy enough to make one coroutine a child of another. We can just call launch or async inside the lambda of another launch or async like I'm doing here. But ultimately, somebody has to provide a scope to use at the root of the coroutine hierarchy. So where does that come from? Well, when starting from a regular main function, you'll use runBlocking. The runBlocking function uses an event loop to make it so that our regular non-suspending functions can create coroutines and call suspending functions. This function creates a CoroutineScope, and the receiver object that's inside that lambda is the scope. So in other words, you can call launch and async inside that lambda, and those coroutines will be children of the coroutine that was created by runBlocking. It's as if we were doing this. The first and most important benefit of structured concurrency is that a parent won't complete until its children complete. And in fact, in this code, the runBlocking function itself won't even return until all of the coroutines inside it have completed. And while it's waiting for those coroutines to finish, this thread that's running this code won't be able to do anything else. It's completely blocked. And that's why this function is called runBlocking. Because this blocks the thread, we really don't want to use runBlocking very often. It's okay at, say, the root of the call stack from within the main function, for example, and you could use it inside of a test function, although you'll probably prefer using the runTest function from the Kotlin X coroutines test library. But it's generally considered bad practice to call this function from anywhere else. After all, coroutines are designed to keep your threads available to do as much work as possible, and they can't do that when they're blocking like this. Well, one place you never want to use runBlocking is inside a suspending function. Remember, a suspending function can only be run by a coroutine, and if we can help it, we really don't want the thread that's running a coroutine to get blocked. Instead of blocking a thread, we want to suspend the coroutine. But you can't just call launch or async directly from inside a suspending function because there's not automatically any CoroutineScope there. So instead, you can call a function named CoroutineScope. In concept, the CoroutineScope function is very similar to runBlocking, but instead of blocking, it suspends. So as I mentioned earlier, the runBlocking function will block the thread, waiting for all of its child coroutines to complete. Well, the CoroutineScope function works similarly, but instead of blocking the thread while waiting for them to complete, it'll suspend its coroutine, and that way the thread that's running it can go off and do other work while waiting for those children to finish. Since CoroutineScope is a suspending function, it can naturally only be called from another suspending function. And by the way, you can mark your main function as suspending, like this, and use the CoroutineScope function rather than a non-suspending main function with runBlocking. So if you find yourself needing to call launch or async inside a suspending function, the CoroutineScope function is what you need. Now there's also a second function that's named CoroutineScope, but this one starts with a capital C instead of a lowercase c. It uses a capital C because it's a factory function. So in other words, it returns a CoroutineScope object. And you can use this to create your own CoroutineScope and call coroutine builders on that. So in this code, you can see down here, I've got this workday class, and inside there, I've created this scope off of the CoroutineScope factory function. And any coroutines that you build on that scope are going to be children of that scope. Now, if all you do is create a CoroutineScope object and use it for a single coroutine in your main function, it's not really going to be that much different than if you were just to use GlobalScope. The real reason to use this CoroutineScope factory function is to create a long-lived scope. So in a lot of cases, a CoroutineScope has a pretty short lifetime, like one that's tied to some operation that you're doing, like loading data for a screen, processing a file, and so on. Well, typically when we create a scope with this function, the intent is that it's going to have its lifetime tied to the lifetime of some other object or workflow. So for example, we could have an application-wide scope where you can load in background jobs or operations that continue to save data even when a screen goes away, for example. And most of the time, when you're creating a long-lived scope like this, you're probably going to build coroutines that shouldn't really interfere with one another. So for example, if an exception is thrown in one background job, you probably don't want it to affect the other coroutines that are doing background jobs in that scope. So for that reason, the CoroutineScope factory function is typically called with a supervisor job like I'm doing here. And it's also not unusual to specify the dispatcher. A scope that's created by this function should be attached to the lifetime of some other object. So for example, an app-wide scope should probably be canceled when the application's shutting down, or if the scope applies to a single screen in your app, then whenever the user leaves that screen, you need to be sure to call the cancel function on it so that all of the coroutines have a chance to stop doing their work and clean up any open resources. But a lot of the time you won't need to create scopes from this function because if you're using a coroutine aware framework, they usually give you a scope to use. So for example, if you're writing a compose app, you can simply use viewModelScope, which is already provided for you. And the framework automatically cancels that scope when the view model shuts down. And similarly, in a KTOR server project, you've already got request level and service-wide level scopes available to you. So before you go creating your own CoroutineScope objects, definitely check to see if the framework you're using already provides them, because if the framework authors did their jobs right, those scopes will automatically be canceled when the right framework events occur. So instead of using GlobalScope, you can get a scope from runBlocking, which is great for creating a scope in the main function. You could use CoroutineScope, which is great for creating a scope inside a suspending function. You can use the CoroutineScope factory function, which can be used to create a long-lived scope that's tied to the lifecycle of some other object, or you can just see if your framework has a scope that's ready for you to use, like viewModelScope or KTOR's request scope. And then, of course, once you've built one coroutine, you can build others inside the first builder's lambda, or pass its scope to another function and build more there. Hey, if you're looking to learn more about coroutines, check out the playlist that I made that includes all of the videos I've made about them. You'll probably want to start with the half-hour presentation since it's a gentle introduction that'll help you get a solid mental model. And if you really want to get a solid grasp on coroutines, I do have an online course that you can learn a whole lot more about them. You can check it out and see if it'd be right for you. In the meantime, remember to like, share, and subscribe, and I'll see you next time.